Ladies and gentlemen, we are doing a one sample t-test for our true slope, so that is for beta. Let's get cruising. Infants who cry easily may be more easily stimulated than others. This may be a sign of a higher IQ. Child development researchers explored the relationship between the crying of infants 4 to 10 days old and later their IQ scores. A snap of a rubber band on the sole of the foot caused the infants to cry. The research recorded the crying and measured its intensity by the number of peaks in the most active 20 seconds. They later measured the children's IQ at the age 3 years using the Stanford-Binet IQ test. A scatter plot and a Minitab alpha for the data from a random sample of 38 infants is below. Okay, do the data provide convincing evidence that there's a positive linear relationship between crying counts and IQ in the population of infants? Okay, the first thing is people always ask me, how do I know if I'm doing an interval or how do I know if I'm doing a test? They say this every time. They will tell you to construct an interval if they want you to construct an interval, okay? Let's get started with the state. What am I looking for in the state? I'm looking for the parameter, the null hypothesis, and the alternative hypothesis. The parameter in that state is our beta, our true slope, okay? I'm going to go ahead and I'm going to type that out. Beta is equal to the true slope, okay? Now, if you need help with context, always use the question to help you with that context. The true slope between crying counts and IQ in the population of infants, okay? Our HO, we always assume, ladies and gentlemen, with our HO that there is no relationship. So we see that beta is equal to 0. And then we have to decide, are we looking for a positive relationship, a negative relationship, or are we just looking for, is there no relationship? I'm sorry, is there a relationship? Can I start over? We're looking for, is there a positive relationship? That would be a greater than. A negative relationship, or are we just looking for a relationship? If we're just looking for a relationship, that's a not equals to. Well, this one says, is there a positive linear relationship? If it didn't have the word positive, if it just said, is there a linear relationship, then that's a not equals to. But because they said positive, it would be greater than 0. If they said negative, it would be negative. And again, if they just said linear relationship, that would be a not equal to. Pause that down right now if you need to write that down as something extra in your notes, okay? Next, we want to write down our alpha. We always, 0.05 in AP Stats is kind of the golden spot for us, unless they tell us something different. Next, we go to those conditions. That's those annoying conditions that we have right now. And again, we're dealing with a linear relationship, so remember liner, okay? Here are all of our conditions. Let's go ahead. I'm going to type these out with us. Plan, okay? L, we want to make sure that our scatter plot is straight and the residual plot has no pattern. Well, if you look here, they don't give us any data really to plug it in. I mean, we could estimate, but that just seems like a mess and not accurate, to be honest. So we are going to have to make some assumptions here. We do see that our scatter plot is straight, and we're going to have to assume that the residual plot has no pattern, okay? Now, in the last video over the interval, we did have data, so I showed you how to check that residual plot on your calculator. Make sure if you haven't watched that and you have questions on that, that you watch that one sample t interval for beta so you know how to check the residual plot and some of these other things that we're going to be making some assumptions on. I, independence. What do we need for independence? That observations or responses are independent of each other. And then if we have a simple random sample of something, we do need to check that 10n as well. Okay? Well, what is our sample size? We have 38 infants. It does state it doesn't state that it's random. So, it does, a random sample. I'm sorry, of 38 infants from below. Okay, so we do want to do that 10n as well. So observations are independent. Okay, N is our normal condition. This is where we want to look at the histograms of the residuals is symmetric. I don't like histograms. I actually like looking at the probability plot personally. And again, I showed you how to do that. Look at the probability plot of the residuals in the last interval. Make sure you know how to use that probability plot feature. That is important. We cannot check the residual plot right now. We cannot check that probability plot of the residuals, so we're going to have to make an assumption. Okay, E, that's that equal spread across that residual plot. Again, in the last video, I talked about if I look at that residual plot and I fold it in half on the x-axis, it should match up somewhat. That's equal spread above and equal spread below. Again, we're going to have to assume that again. And I think in the interval, I maybe said it just a little bit differently, but that doesn't matter. Residual plot, I said it, instead of equal spread, I said consistent spread everywhere. Same thing, essentially. And then R, and we already checked that R. It is a random sample of 38 infants. I'm typing. You can see all my typing errors that I make here. And then our method now. Our conditions they're okay, so let's keep going. A one sample t-test for beta, or for the true slope you could put as well. Let's go ahead and let's go to the board for the do. What am I looking for the do picture? The statistic, standard error, t-squared, degrees of freedom, and the p-value. I have lots to talk about in this one, ladies and gentlemen. The do is always my favorite because that's where we get to find that p-value, and that p-value tells us if we can reject or fail to reject that null hypothesis, my favorite part of the whole thing. So I'm going to draw this curve. In the center of the curve, remember, is always our mean. That's what our null hypothesis, it's the parameter that we believe to be true right now, and we believe that that parameter to be true right now is beta is equal to 0. There's no relationship right now. That's our assumed truth, and we're trying to prove that there is a relationship. In fact, we're trying to prove that there's a positive relationship. So we get a statistic. Well, what is that statistic? That statistic is our slope. And our slope in this case, remember, it goes in order. Y hat equals A plus BX. Our slope is B. We have our A, and then we have our B right here. So here is our statistic, 1.4929. 1.4929. So let's put that down here. We're going to shade to the right. And then we have our standard error of our statistic right here. Our standard error for our slope for B. Just put that there so we know it's our standard error for that slope. And that is right here. And we learned about this mini-tab output and what all these numbers mean in the last, or in 2 videos ago, as well as the last video. So make sure you check out those videos if you haven't seen it, because I talk more in depth about that. We have our standard error right here, which is 0.4870. Okay, you're going to really like the do part because they give you everything when they give you a mini tab output. So next what I need is I need that t-score. That's Tom's. Tom's, remember? What we observe minus the mean divided by the standard deviation or standard error of that statistic. Okay, so I'm going to take my observation, 1.4929 minus my mean divided by 0.4870. And I want to show you something up here, ladies and gentlemen. You're going to like this. If I look at my mini-tab output, right here, 3.07, that's my t-score. So 3.07. Now we need to find our p-value for our degrees of freedom. Remember, it's n minus 2, so that's 38. Minus 2, our degrees of freedom, is 36, and we don't have to use the table for this as well. What they do, ladies and gentlemen, is they give us our p-value right here. There is a catch here, though. This p-value on the mini-tab only works for an HA where it's a not equal to, an HA where it's a not equal to. Well, we don't have a not equal to. We have a greater than. Okay, we have a greater than. Give me a second here. So you can see that greater than right there. Okay, So what I need to do, since it's a greater than, the p-value that they gave us is 0.004. We need to divide this by 2. This is a special note. Why do I need to divide it by 2? Because what they gave it to us was a two-tailed test. If it was a not equal to, we would have this value over here. We don't have that. We only have a one-sided. So whenever it's a greater than or a less than, so mark this as a note, whenever it's a greater than or a less than for your HA, and you have a mini tab output, you need to take that p-value and you need to divide it by 2. So when I take my p-value and divide it by 2, my p-value is actually 0.002. And now I'm ready to conclude. Okay, now I'm ready to conclude. So I'm going to go back and I'm going to type for that conclusion so it looks a little bit better for you guys. 0.002 is less than alpha 0.05. We reject the null hypothesis, and we have evidence that state to help you here. The true slope between crying counts and IQ in the population of infants is greater than 0. The p-value 0.002 is less than alpha 0.05. We reject the null hypothesis, and we have evidence for HA that the true slope between crying counts and IQ in the population of infants is greater than 0. Make sure, ladies and gentlemen, I'm going a little bit faster through some of this stuff because I've already, you guys know a state plan do conclude. Really, there's just a couple of little curveballs that I've thrown at you. The biggest one would probably be the conditions, right? Make sure that you know how to interpret what a p-value is. That's the probability of getting a statistic as extreme or more extreme than what we calculated, given that null hypothesis is true. Make sure you know that confidence level interpretation. These are things that are still connected, and we're not always practicing them in the notes, but they'll pop up on the homework. Make sure you still remember what that type 1 and that type 2 error is as well. Those are all connected to inference, ladies and gentlemen. Well, we're done with that one sample t-test for slope. Make sure you write down any questions you have, and I hope you guys all had a great day.